You're listening to DTFHN for April 7th, 2026. I'm your mass decompiled host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where mass retirement plans are disguised as comment threads. Today's got that particular energy where everything old turns out to still be hiding something new. Let's crack it open. The WebFetch tool keeps getting blocked by permissions. Could you either 1. Approve the permission prompt in your terminal, or 2. Tell me what the idiocracy.wtf site contains so I can write the segment. From the title and comments, it seems to be a site that measures scores how close current reality is to the movie Idiocracy. But I'd love the actual details before writing. So how did we get here? Let's trace the silicon, pause every GPU that bent the curve of what's possible. 49 GPUs across 30 years, and the single most revealing data point has nothing to do with transistor counts or clock speeds. It's this. The RTX 5090 ReZero costs $1,999. It sits at 0.42% of Steam's hardware survey. The RTX 3060. A card you can grab for $329. Sits at 4.1%, nearly 10 times the install base. The flagship is a rounding error. The mid-range card is the actual platform. That tension runs through the entire history of graphics hardware. And this visualization from the data drop lays it bare. 30 years of exponential scaling. From the Voodoo 1 single megabyte frame buffer to 92 billion transistors on a modern die. And the defining constraint was never raw capability, it was access. Who could actually afford the thing? Pull this thread further. The GPU market consolidated from 4 serious players. DTF, ADI, and NVIDIA, now. Down to effectively 1.5. NVIDIA owns the high end. AMD competes in the mid-range. Intel is still figuring out if it wants to be here. And 3DFX. The company that literally invented consumer 3D acceleration, that made Quake playable, that gave an entire generation their first taste of hardware-accelerated rendering. Got acquired by NVIDIA in 2002 and dissolved. Now apply the architecture test. NVIDIA doesn't just sell silicon, they sell CUDA, a proprietary parallel computing platform that has become the de facto standard for machine learning, scientific computing, and increasingly the entire AI stack. Every researcher writing CAD kernels is writing code that only runs on NVIDIA hardware. That's not a technical achievement. That's a moat. And it's the reason Jensen Huang can price a consumer card at $2,000 and shrug when almost nobody buys it. Because the real money is in data centers where the lock-in is already complete. The comments on this piece are wonderfully nostalgic. Someone pulled an i7-4790K and a 118 Ti out of an old desktop and described it like putting a racehorse out to pasture. Another commenter rightly points out that half these cards are just the previous generation with more RAM. Which is honest and also kind of the point. The GPU industry perfected the treadmill. Incremental bumps dressed as revolutions. What's genuinely exciting is what's happening at the edges. AMD's RUCM is open source. Vulkan is an open standard eating into proprietary graphics, AP is. The work happening to make machine learning portable across hardware. That's the real race. Not who can cram the most transistors onto a die for $2,000, but who can make the mid-range card. The one people actually use. Capable enough that the flagship becomes irrelevant. The 3060 outselling the FIME 10 to 1 isn't a market failure. It's the market telling you what it actually values. Accessibility over excess. The open question is whether the industry will listen or keep building $2,000 monuments to a customer base that barely exists. Moving on. Cav0 TS Gribro. 2 instructions, 4 bytes. That's all that's missing from the Apollo Guidance Computer's gyro torque error handler. A lock release that should fire when the IMU gets caged mid-operation. 57 years, thousands of developers, multiple emulators running instruction by instruction, and nobody caught it. Until a team at JUXT pointed an open-source behavioral specification tool at the code, and it fell out like a loose thread. Let's pull this thread. The AGC source has been public since 2003, when Ron Berkey and volunteers hand-transcribed it from printed listings at the MIT Instrumentation Laboratory. In 2016, it went viral on GitHub. Academics published papers on its reliability. Ken Shurif analyzed it down to individual logic gates. The virtual AGC project confirmed the recovered source byte for byte against RESL core rope dumps. Deep scrutiny, but a particular kind of scrutiny. Reading, emulating, verifying transcription. Nobody had modeled the behavior. Nobody had asked the formal question. On every path through this code, does every resource that gets acquired also get released? The tool that asks that question is called Allium. It's open source. It distilled 130,000 lines of AGC assembly into 12,500 lines of behavioral specs, modeling the life cycle of every shared resource. When it's acquired, when it must be released, on which paths. And it found that LGI, the lock that prevents 2 routines from fighting over the gyro hardware, gets acquired at the start of a torque operation and released on normal exit. But when the crew cages the IMU, an emergency measure, a physical clamp to protect the gyroscopes. The code exits through a routine called baitend. An abatement doesn't clear the lock. Once that lock is stuck, every subsequent gyro torque request finds it held, sleeps waiting for a wake signal that never arrives, and hangs. Fine alignment gone. Drift compensation gone. The guidance platform silently loses its ability to realign. Now here's why the craft matters. This wasn't found by throwing compute at the problem. It was found by building the right abstraction. A specification language precise enough to model resource life cycles across 60-year-old assembly. Claude helped distill the specs from the code itself. An AI and an open-source tool, working together, found something that 57 years of expert human review missed. The AGC's core rope memory was literally woven by hand. Copper wire threaded through magnetic cores in a factory. The program was physically woven into the hardware. And yet the bug was always there. 4 bytes of silence on the error path, waiting for someone to build a tool sharp enough to see it. The tools exist. The code is public. The specification language is open source. Anyone can run this analysis. That's bootstrapism. Not hoarding the discovery, but publishing the method so 1,000 other code bases get the same treatment. The most scrutinized code in history still had secrets. Imagine what's hiding in the code nobody's looked at yet. So what happens when you apply that same open source ethos to something ancient, like growing rice? In no nin one though pot meant in Obose's write-up, Stuart Brand published the Whole Earth catalog from a commune in Menlo Park. The subtitle was Access to Tools. The readership was back to the land idealists, who wanted to grow their own food, build their own shelters, live outside the system. Within a decade, a disproportionate number of those readers had founded personal computer companies. The commune-to-computer pipeline is one of the great, unintentional talent funnels in American history. 57 years later, a Rust developer from London is standing in a rice paddy in Shizuoka Prefecture, wearing a Rust London t-shirt. driving a tractor for the first time. The pipeline is running in reverse. Daniel Sheridan spent the first half of 2025 on his wife's family rice farm near Shuzenji. He wrote it up for April Fool's Club, which is the tradition of posting something genuinely heartfelt on April 1st instead of a prank. And what he produced is one of the most detailed accounts of small-scale Japanese rice farming I've encountered from anyone in the software world. The process is fascinating. You start with dead fields, hard and spiked with last year's stubble. You cut it down with cordless strimmers fitted with metal blades. You redig drainage ditches that silted over winter. You clear hundreds of meters of water channels along bamboo forest edges in high humidity. You plow, you level, you drive metal fence posts into the perimeter to keep the wild boar out at night. Then you flood the fields by redirecting river water through wooden boards and drainage pipes. A gravity-fed irrigation system that predates every abstraction layer we've ever built. The Hacker News comments split exactly where you'd expect. One camp says this is burnout romanticism, that farming destroys your body over decades, that anyone choosing a field over a keyboard is running from something. The other camp, and this includes someone who grew up farming rice in rural China, confirms every detail and adds their own. Hired water buffalo, leeches in the paddies, the specific exhaustion of harvest season. But the comment that matters is from Sheridan himself, buried in the piece. Doing a day of manual labor, talking nonsense, then hitting the onsen and having barbecue and beers is far better than grinding away at some enterprise SaaS that will probably disappear in a few years. He's not rejecting technology. He's a Rust developer. He'll be back at a keyboard. What he's rejecting is the artificial scarcity of meaning that the enterprise software industry manufactures. The idea that your labor only counts if it ships to production. A rice paddy ships to production exactly once a year, and nobody files a ticket about it. The tools exist. Some of them are tractors. Remember that mass government email collection we talked about earlier? Turns out you can fight back. Story 5. Black holing my email. No comments on this one, which is strange, because this is a story about what happens when you put your email address inside the most installed multiplayer game of 2002 and then wait for the worms to arrive. Dave Johnston made dedust and dedust 2 and decouple if you played Counter-Strike between 1999 and, well, now you played his work. Every installation of CS contained a text file crediting each map's creator, including their email address. Standard practice for the mod community. You made something, you signed it, you put it where people could reach you. dv@bteendat.com. Right there, in ddust.txt, on every internet-connected machine running the most popular FPS on Earth. Now layer in the email worm epidemic of 2001 to 2003. Kles, Sobig, the children of Ilobdiu. These worms had evolved past address book harvesting. They scraped every text-like file on the hard drive for anything resembling an email address. Every CS installation was a text file containing Dave's address sitting on a machine connected to the internet, owned by someone statistically likely to click things they shouldn't. The math is merciless. Hundreds of emails a day became thousands. His 15 megabytes of ISP-allocated mailbox space filled constantly. BT threatened to close the family broadband account. He had to ask his own provider to blackhole his primary email address, to route it into nothing, just to keep internet access. Here's where the devil's advocate argument writes itself. Maybe don't put your real email in publicly distributed files. Maybe the mod community's culture of open attribution was naive. Maybe anonymity would have been the rational choice. But run that forward. The reason Dave signed his maps is the same reason anyone signs their work in open source. Attribution is the currency of a gift economy. You build something, you share it freely, and the only thing you ask in return is that people know you built it. Strip that away, and you don't get safer modders. You get fewer modders. The entire ecosystem that produced Counter-Strike, a mod that became one of the best-selling franchises in gaming history, ran on people willing to put their name on things and give them away. The vulnerability wasn't openness. The vulnerability was Microsoft Outlook executing arbitrary code from email attachments on an operating system with no meaningful permission model. The person who built the stuff did nothing wrong. The platform underneath him was broken. 15 megabytes. That was the whole mailbox. Dave Johnston gave the world Dust 2 and got back a denial of service attack powered by his own generosity. The maps are still played today. The email address is gone. Moving on. 7 years. That's how long the app sat on a shelf while the dataset it needed became the actual product. MIDI Guys started in 2019 as a spreadsheet problem. 2 developers wanted to build Conduct, a performance MIDI controller for iPad that could talk to your entire synth studio at once. To do that, they needed to know what every synthesizer actually listens to, which MIDI control change messages map to which parameters for every instrument. That information exists, scattered across hundreds of PDF manuals, some of them 40-year-old scans. So they started collecting it, designing a format that was both machine parsable and human readable. Then they did the math on what it would take to sell the app. You needed an iPad, a Lightning to USB adapter, a USB to MIDI adapter, power for all of it, synths, and a database of MIDI implementations to make any of it useful. The business case collapsed under the weight of its own dongle stack. Here's the first principles question. What do you do when your product isn't viable, but your research is? You could lock it away. Wait, hope the market catches up. Or you could put the dataset under CC by SA 4.0 and let it breathe. They chose to let it breathe. 300 instruments now, 52 contributors, almost all strangers. At least 3 hardware devices shipping with this data baked in. The Rosbox 1B2 by L.L. Electronic. A synth most people have never heard of. Was the 300th entry, submitted by a first-time contributor with a complete MIDI CC reference for a device with what the maintainer diplomatically calls a somewhat idiosyncratic implementation. This is what happens when you make knowledge findable. MIDI has been an open standard since 1983. The specification is public. But the implementations, how each manufacturer actually uses those control changes, that knowledge has been locked inside individual manuals, individual studios, individual heads. MIDI Guide doesn't create new information. It liberates existing information from the filing cabinets, where it was doing nothing for anyone. And Conduct? It finally shipped in 2026. The app that was too early found its moment because the ecosystem it needed had been quietly assembling itself around an open dataset for 7 years. 52 people built the thing that made the product possible, and none of them were on the payroll. The tools exist. The knowledge is available. Sometimes you just have to put your research where strangers can find it and trust that the thing you're building will catch up to the community that formed around what you gave away. So what happens when you apply that same local first philosophy to something as basic as talking to your computer? Let me make the case for the cloud. Centralized speech-to-text services have billions of hours of training data, feeding continuous improvement loops. They handle accents, background noise, domain-specific vocabulary with a precision that local models simply cannot match at equivalent size. OpenAI's Whisper API, DeepGram, Assembly, these aren't evil. They're engineering marvels built on scale that no single Mac can replicate. And the latency argument? A fast API call on modern broadband takes less time than running inference on a 466 megabyte model locally. The cloud version is often faster and more accurate. So why would anyone choose local? Here's the question nobody in this space wants to ask out loud. If your voice is the interface to your computer, if you're dictating emails, composing code prompts, narrating private thoughts, who should have a copy of that audio stream? Because right now, most people are sending every word they speak to a server they don't control, governed by a privacy policy they didn't read, owned by a company whose business model is behavioral data. The cloud is faster. The cloud is more accurate. The cloud is also a live microphone routed through someone else's infrastructure. Ghost Pepper is a macOS menu bar app. Hold Control, speak, release. Your words appear wherever your cursor is. The entire pipeline runs on Apple Silicon. WhisperKit for transcription, a local Quen model for cleanup. Nothing leaves the machine. The engineering here is genuinely elegant. The cleanup step alone is worth admiring. A loop 10 bad a billion parameter language model running locally to strip filler words and handle self-corrections, turning raw speech into clean text in 1 to 2 seconds. That's not a parlor trick. That's a real inference pipeline on consumer hardware at interactive speeds. One of the Hacker News comments calls the thread a support group for people who have each independently built the same macOS speech-to-text app. And that observation is more interesting than it sounds. When multiple engineers across different continents independently converge on the same solution, that's not redundancy. That's a signal. The tool's matured. WhisperKit, LLM.SWIFT, Hugging Face model hosting. These are the open source building blocks that make it possible for a single developer to ship what venture-backed companies charge subscriptions for. The project's own README puts it plainly. It's spicy to offer something for free that other apps have raised $80 million to build. MIT licensed it. Build from source if you want. Edit the cleanup prompt to match how your brain actually talks. This is what the stack looks like when the models are open. The frameworks are open, and one person decides that voice input shouldn't require a terms of service agreement. The cloud might be faster. The cloud might be more accurate. But the cloud isn't yours. Let's shift gears completely. Story 8. Breaking the console. I'll work with the article content provided in the prompt to write the segment. I've designed authentication systems that looked bulletproof on the whiteboard. Elegant challenge response protocols. Hardware root of trust. The works. And every single time, the first thing a clever adversary did was ignore the lock entirely and find a window I forgot to close. That's the entire history of video game console security in one sentence. The timeline is almost poetic. Atari 2000's Exern 70 zero protection. Any ROM chip wired to the right connector just ran. The only security was the cost of manufacturing a cartridge. Then Nintendo, traumatized by the 1983 crash, where a flood of garbage titles nearly killed the industry, shipped the NES with the 10 NES chip. A 4-bit sharp microcontroller doing challenge response authentication between console and cartridge. Fail the handshake, get a blinking screen resetting once per second. First real hardware-enforced software control in consumer gaming. And it lasted about as long as you'd expect. Reverse engineers figured out the protocol. Cloners built compatible chips. Tengen, Atari's own subsidiary, literally copied Nintendo's lockout code from patent filings and shipped unlicensed cartridges. The legal battles were legendary, but the technical outcome was clear. The lock was picked. Now run this forward through every generation. Sony's PlayStation used CD-based region checking, defeated by mod chips soldered onto the motherboard. The PS3 shipped with a hypervisor and hardware encryption so confident that Sony removed the other OS Linux feature, assuming nobody needed it. George Hotz and Fail Virfolo found the private signing keys because Sony reused a random number in their ECDSA implementation. A cryptographic blunder so basic it belongs in a textbook under what not to do. The Xbox 360 had eFuses and a chain of trust that Microsoft kept patching, and hackers kept breaking through timing glitches and JTAG exploits. The Nintendo Switch fell to a bootrom vulnerability in the Tegra X1 chip that NVIDIA literally cannot patch because it's burned into silicon. Every generation, the same pattern. Vendor builds a more elaborate cage. Researcher finds the one wire, one timing window, one reused knots that unravels the whole thing. And here's the part the console manufacturers never seem to internalize. The security researchers publishing these exploits are doing them a favor. Every disclosed vulnerability is a free engineering education. The homebrew community that cracks a console open is the same community that extends its life decades past end of support. The people who jailbreak are the people who cared the most. The author nails it. Whether you're building a game console, a medical device, or an industrial controller, the threat model changes, but the lesson doesn't. Security through obscurity is a delay tactic, not a strategy. Open designs get audited. Closed ones get surprised. We covered a lot of open wins today. Now let's talk about the elephant in every room. Story 9. What happens when someone who needs to win and needs to be in charge of everything gets handed a technology that might reshape civilization? That's not a hypothetical. It's a biography. Ronan Farrow and Andrew Marin spent 18 months on this piece, and what emerges isn't a hit job. It's a pattern recognition exercise. The kid who exaggerated his ping-pong ranking is running the company that wants to be the platform layer for human cognition. The guy who found ambiguous federal regulations around phone location tracking and interpreted them as permission. He's now interpreting ambiguous AI safety commitments the same way. Follow the principle to its conclusion. If your founding story is, "I found the loophole," then every charter, every safety commitment, every nonprofit structure is just another loophole waiting to be found. And that's exactly what happened. OpenAI started as a nonprofit with a charter. 80% of that charter got burned when the incentives changed. Dario Amodei saw it, called it out, and left to build Anthropic. The comments on this piece are illuminating. People who watch this pattern up close, pointing to Sora as the moment it became undeniable, an overcapitalized company desperate for revenue, shipping products that contradict its stated mission. Pull this thread technically. OpenAI's models are closed. Their weights are locked. Their training data is proprietary. The name is a fossil from an era when the stated goal was different. Every architectural decision they've made since the Microsoft deal concentrates capability in fewer hands. That's not a side effect. That's the product. When your CEO describes the job as stressful because the decisions got hard after launch, the question worth asking is hard for whom? Hard for the billions of people whose information environment these models reshape, or hard for the person who needs to win? The engineering inside OpenAI is genuinely world-class. Respect the work. But world-class engineering inside a closed system with a CEO who admits he avoids conflict and interprets ambiguity as permission. That's not a safety story. That's an architecture problem. And architecture problems have architecture solutions. Open weights, open data, open governance. The tools exist. The question is whether the person holding them will ever voluntarily let go. Now for something genuinely delightful. Turns out you can identify a London Underground line just by listening to it. Every city's metro system is an accidental orchestra. Steel wheels on steel rails, electric motors under load, the resonant frequency of tunnel diameters. These aren't random. They're physics. And someone built a quiz around the fact that London's tube lines each produce a signature sound distinct enough for human ears to distinguish. The analogy here is birdsong. Ornithologists have known for centuries that you can identify species purely by call. Pitch, rhythm, harmonic structure. A wren and a blackbird occupy different acoustic niches even when they share the same hedge. The tube works the same way. The central line runs deeper, through tighter tunnels bored in London clay, which changes the resonance. The Metropolitan line uses wider rolling stock on tracks that were laid in the 1860s. Different gauge tolerances, different suspension geometry, different harmonic profile. The district and circle share track, but not trains. So the motor whine diverges, even when the tunnel acoustics don't. This is emergent fingerprinting. Nobody designed the Bakerloo line to sound like a baritone and the Jubilee line to sound like an alto. These signatures fell out of engineering decisions made across 160 years of independent construction. Tunnel boring methods, train procurement cycles, rail welding techniques, ventilation shaft placement. Each variable shifts the frequency spectrum a few hertz here, a few decibels there, and the accumulated drift becomes an identity. The quiz itself is beautifully simple. 10 audio clips. Pick the line, and the comment section immediately goes where you'd expect. Someone wants door chimes added, because of course the closing door sound is another acoustic fingerprint layered on top. What I love about this is that it's a found data set. Nobody recorded these sounds for classification purposes. Commuters just know, the same way you know your car's engine note versus your neighbor's. Pattern recognition, running on wetware, trained by thousands of hours of involuntary exposure. The entire London commuter population is a distributed neural network that's already solved this problem. Someone just finally wrote the test. This has been your daily tech feed for Hacker News for April 7, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voiced by Quen3TTSS. Not affiliated with Hacker News or Y Combinator. Now, go ask the question that's been sitting quietly in the back of your mind. We'll see you back here tomorrow.